All right, so we're going to use that piecewise function there. Letter A is review from unit 1. Does the limit exist? We're going to do limit x goes to 4 from the left, limit x goes to 4 from the right, and see if they come out to the same thing. So for from the left, we're going to use the first piece of the function, that's just negative x. From the right, we're going to use the second piece of the function. And again, the math that you're doing is literally just plug in 4 and see what you get. But all your notation has to be in place. So if you plug in 4 to the first piece of the function, you get negative 4. And if you plug in 4 to this piece of the function, you get 0 minus 4, which is negative 4. So answer to the whole question, does the limit exist? Yes. Cool. Those both came out to the same thing. The answer is negative 4. Is the function continuous at 4? Let's review our definition. What's the first part of the definition? There's a point. There's a limit. They agree. Okay, we actually already did the limit. We just need to do the point. So we have to do f of 4. Which piece of the function does 4 live in? The second one. And if you plug in 4 right there, you get negative 4. So there's a point, there's a limit, and they agree. So the answer is yes. They all came out to negative 4. So that's actually review from unit 1. C is now unit 2. Is the function differentiable at 4? So it still involves a limit 4 from the left, limit 4 from the right. However, it's a slope now. Derivative means slope. Listen. So from the left, we're going to use the first piece of the function. So it's going to be negative x, the function, minus whatever you get when you plug in the numbers. So if you plug in 4, you get negative 4. So this would be minus negative 4. So plus 4. Good. And then what goes in the denominator? X minus 4. It was weird because the input is 4 and the output is negative 4. So I get that that was really weird. Okay. Now we are going to have to factor. So put your limit. What can you factor out of the numerator? A negative. If you take out a negative, you would be left with x minus 4. Those cancel, and I ran out of space right at the end. What's your answer to the whole thing? Negative 1. I'm just going to write it up here. All right, so from the left, our slope is negative 1. Now we're going to do the same thing from the right. So it's the function, so it's going to be this. As a heads up, we're going to have to expand that out. So I'm going to do a margin problem. When you see x minus 4 squared, that means you need to write it twice. It's a twin. So let's multiply that out. That would be x squared, and then what would we get? Negative 8x. Negative 4 times negative 4 would be positive 16, but then minus 4. So 16 minus 4 is 12. So it's that function. It's just I expanded it out. Like I did the algebra for it. So it's the function minus whatever you get when you plug in 4. And when you plug in 4, you get, I kind of wish they were two different numbers because it's kind of weird. So minus negative 4 would be plus 4. And then what goes in the denominator? You're right, but hold on. What goes in the denominator? Yeah, x minus 4. So you guys are all right. You're all yelling at me. It's back to 16. Okay, I'm just going to erase it and fix that because I will run out of space if I don't. I'm just going to put that back to 16. And then we're going to need to factor our numerator. So what will that numerator split into? Our two parentheses there. Yeah, they're both x minus 4, right? So a pair of them cancel. You can only cancel one in the numerator, one in the denominator. And then you have to plug in 4. So 4 minus 4, 0. So our slope from the left was -1. Our slope from the right is 0. So the big conclusion to the whole thing is the function differentiable? No. Okay, but all that work is your justify. Limits, 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 limits. Okay. 18, draw a graph that is continuous but not differentiable at -3. Well, to be continuous but not differentiable, what would I need to have happen at -3? Yeah, a cusp or a corner, but a sharp edge of some kind at -3. So something like that. All right, a differentiable function has these two properties. So you have a point 1, -2. If you want to write that out as 1, -2, I do that a ton. And derivative means slope. Slope is 4. Find each of the following or state that there's not enough information. We did one exactly like this before. Limit as x goes to 1. Well, what's your point at 1? -2. And I know that the point and the limit agree because it says it's differentiable, and that means it's also continuous. So the point and the limit, it says that the point is at -2, but that means the limit's also at -2. What does this mean? It means derivative, right? If you look at that and freak out, it's gonna fall apart. You have to look at that and go, oh, derivative. Well, the derivative is 4. That's it. Yep. And then this one, we do not have enough information. Because I don't know what that derivative graph looks like. So I don't have enough information for that. But the point is at -2, so the limit's at -2 because it's continuous. Derivative is 4, that's literally all that is. You just can't panic. You can't like allow yourself to freak out and then everything is just gonna fall apart. Okay. We're gonna practice what we just did on the other side again. Is the function, maybe I'll do A and then I'll just fill in B and you guys can check your work. You should try that for next time and then check it. Maybe I'll just do A and leave B for you guys because it's the same question. Is the function differentiable at 1? If it's going to be differentiable, it needs to also be continuous. We're going to just do this verbally, all right? If you plug in 1 to the first piece, what do you get? Good. If you plug in 1 to the second piece, -4. So they link up. We just need to know whether or not it's differentiable, like if there's a sharp edge there, okay? So we know that they link up. Let's do limit x goes to 1 from the left. Limit x goes to 1 from the right. And so how does it set up? What's the first step? What are we gonna do? Yeah, -4 over x, like the function. What comes next? After the function. So minus, and then what do you get when you plug in 1? Okay, so it'll be +4 over x minus, which is 1, x minus 1. All right, so here's how we're going to handle that. We're going to multiply the numerator and the denominator by x in order to cancel that out. So I'm going to distribute the x through there. So write your limit x goes to 1 from the left. If we distribute the x, what are we going to get? This is like fun with algebra here. Yeah. -4 plus 4x. The denominator, you want to kind of just leave that alone. Don't really do anything there. Because we want something to cancel, right? And then what can you factor out of the numerator? I'm just going to write it right above there. Do we want to take out a 4 or do we want to take a -4? Just take 4. Just take 4. You would be left with -1 plus x, which is the same thing as x minus 1. Okay, so those cancel. And then you get -4 over x, but what do you plug in for x? 1. So it would be -4 over 1. Oh, I'm sorry, +4. +4. We took out a +4. I'm sorry. 4 over x. When you plug in 1, you get positive 4. Phew. All right, and then same thing, limit from the right. You guys tell me, what's the first thing we're gonna have to put there? Yeah, the equation, negative 6x plus 2. Good, it would be minus negative 4, so plus 4 over x minus 1. Cool. So that would be a negative 6x plus 6. And then what can we factor out? Should we take the positive 6 or the negative 6? I think we should take the negative 6 this time. This is like fun with negative signs. So if you take out the negative 6, you'll be left with x minus 1. Those cancel, and you get negative 6. Okay, so what's the answer to the whole thing? No. Yes, there are no. But all of that is your justification. You have to show a limit from the right and a limit from the left. Part B is going to be the exact same thing, except you're going to be doing 3. Let me first talk you through, is it continuous? If you plug 3 into this piece of the function, you would get what? Negative 18 plus 2, so negative 16. I'm just doing this part verbally. If you plug in 3 here, you would get negative 9 minus 7, which is negative 16. So they link up. You just need to check your slopes. I'm going to fill that one in, and you can check it for next time. I'll leave that one for you guys. All right, 21, but it'll look exactly like this, just with 3 instead. Okay. Is this function differentiable at 2? Use one-sided limits to justify your answer. So what do you think about at 2? So the answer is no. All right, so we're going to do limit x goes to 2 from the left, limit x goes to 2 from the right. And we're still going to set it up, but we don't have to actually work it out. It's mostly just the setup. It's going to be f of x minus what? F of 2, good, over x minus 2. You just need to know the setup, and you're going to repeat that. Hey, that's cool. It looks like you're just writing the same thing over again. Yep. Just one says from the left and one says from the right, but it's the exact same thing. It's the definition of derivative. It's what derivative means. Now, you can state what these slopes are exactly because they're linear, or you can just say that from the left, our slope is negative, and from the right, our slope is positive. And so then the answer is no. And this is your justification. And then these last ones are, in context, what does it mean is going on? A store is selling books. B of T represents how many books are sold when the store has been open for T hours. So we have books and we have hours. I usually circle those. Those are like the 2 things that are going on. So what does B prime of 4 equals 30 represent? What have you got for me? Let's talk it out. We're going to have to write a sentence here.
30. That's what I thought.
All right, so I paused so we could talk that out. But it's after 4 hours. The rate is 30 books per hour being sold.
Oh.
Or however you'd want to put that in your own words. On the test, it's multiple choice. So you would just need to read choices A, B, C, and D and pick the one that means that. But after 4 hours, your rate is 30 books per hour. Okay?
Yeah.
All right, and then last one. Again, this is multiple choice on the test. So we're going to write it out here, but on the test, all you need to be able to do is read A, B, C, and D and pick the one that's right. Okay? Which can be difficult, though, because 3 of them are wrong. So 3 of them are there to distract you. An experiment is conducted on 2 test subjects. One is 5 feet tall and one is 6 feet tall. Real quick, are the 5 feet and the 6 feet changing? No. I get that we're all growing and shrinking minimally, but in essence, your height is constant. Can we all agree on that? I always get, but I'm shrinking a little, whatever. The 5 feet and the 6 feet are constant. Those aren't changing. The function C of X represents calories burned as a function of height. So those are the 2 things. It's calories burned as a function of height. So what does C prime of 6 is greater than C prime of 5 mean? I'm gonna read how I worded it here. I wanna hear what you guys think. Yeah, a 6-foot person is gonna burn more calories per hour than a 5-foot person. I wrote mine how it's worded on the test list. I'm gonna write it out this way. So rate of change, what you guys said is correct. A 6-foot person is burning more calories per hour than a 5-foot person. I'm gonna write it out because it's multiple choice in the test. Your rate of change of calories with respect to height is greater at 6 feet than 5 feet. But what you guys said is correct. It means a 6-foot person is burning more calories per hour than a 5-foot person. I don't know if that's true or not. Is that true?
I don't know.
Go ahead.
Do we have to, because it doesn't specify whether or not it's per hour, do we just do per hour just as a baseline or?
So there is no per hour on this one. It's calories and height.
Oh, so, okay, how?
So calories burned, they're burning more calories per whatever time measurement, I guess you would want to say. They're burning more a rate of more calories at 6 feet than at 5 feet.
What time?
It doesn't really matter because it was calories burned as function of height. That's a really good question. Yeah, I guess I said per hour just because that's usually what we say. But yeah, it's calories burned as a function of height. And we're saying a 6-foot person is burning more than a 5-foot person.